at this point, you probably already know that magnets have a north or a south side. If we try to put two of the same pole together, no matter how much we might force them, they don't want to stay together, so the field pushes them apart. If we have two magnets with opposite poles, a north and a south, they attract each other over a distance. In this case, we can see them even moving a distance through the air to be in contact with each other. Now, magnets can also cause things that are not normally a magnet to become a magnet. These paper clips don't normally have a magnetic field, but when around a strong magnet, they create one of their own, attracting each other and attracting themselves to the magnet. Now, if I turn the middle magnet, I see that the magnetic field is somewhat disrupted, right? And the paper clips fall down until I put them back in place. Once again, we see them hovering in the air due to this magnetic attraction. Now, what's going on in the next part is a little bit complicated, but to give you a basic idea, we have a magnetic ball and two containers that would not normally be magnetic. The material they make them out of is not particularly magnetic material. But by putting a strong magnet through them, we can induce a magnetic current through them that creates these things that we call eddy currents that slows the fall. So when we put the magnet through the two containers, it falls pretty slowly. When we put the tomato through the containers, it falls nearly instantly. It's hard to even count how long, but when we look at the magnet, we can count 1, 2, 3 before it hits the ground. This allows us to do some cool tricks. I can turn it back and forth. The magnets fall slow enough, or the magnet ball falls slow enough that it only goes through when I allow it. The tomato, sadly, doesn't work the same way. If we look at the two separate, we can kind of see what's going on inside.